guys, Pat here from Rain Country. God is good all the time, even in these weird times. Anyway, last year I got a box truck, pretty good shape. It used to be a lube truck, and I'm transforming it into a moving truck or shop truck or a multitasking, multi-use truck. And it's just working on a couple of simple things, and one of these things are these bin doors on the inside. This one here has a messed up latch on it, so seeing if I can repair it with what I have on hand. That's the normally closed position. You're supposed to be able to turn the handle, but as you can see, it doesn't even come up tight. It's just haywire. And it don't look like that's the original bolt that was in there, and somebody put some, looks like a couple more washers in there to shim it out, and did a, well, they failed. Okay, yeah, these are supposed to be facing up. These little bars here are supposed to be facing up. And what they do is they run back and forth and secure to the back side of this frame on the cabinet itself. So when it's closed, those run forward, and when they open the cabinet, that side and this side is supposed to open up. Well, there's no bar here, as you can see on this one. This is a complete one. It works. See how that rotates back and forth when you turn the handle? This latch secures to the back side of the cabinet here, and then these little posts run in and out to latch on the back side of the cabinet here. So what we need to do is make this handle on the defective one function again, and we also need to duplicate another one of these rods for this missing one on this side. So the first thing we want to do is disassemble this. Not only would we have a missing rod to the other side, we have a round peg into a square hole. So this is turning inside that. It's all wore off there into a circular shape. So we have to make that square again. So what I need to do is I need to take this handle apart and see if I can reproduce this part here that's actually runs through here that rotates on this. There's a pin, a shear pin that runs through here. So I have to remove that shear pin and remove this piece, and there's a couple of parts here that I just have to remove off here and just duplicate this. So we'll go back over to the house and I will see if I can take this apart, see if I can find some parts over my junk pile over there, one of my hillbilly piles, and see if we can't reproduce that part. Cody, come! You ready to go? Okay, here I come. Okay, here we are at the house, looking through all my scraps and whatnot. Here we have to duplicate another one of these, and we have to duplicate this part right here, this little cylindrical part with a square edge on this side here. That might be a little tricky, but let's see if we can figure it out. So what I have is I have a couple of punches, and those will be used to drive out our pin. Size on our rod, it's 0.3. I found another rod the same diameter, 0.3, and it's long enough to where it'll work. It's actually got a flat side on it, but it's not long enough. I'll have to cut this off, bore this hole bigger after I flatten this out some more, and then we'll cut it to length. So we have a drill bit that'll be used to make our hole bigger in this piece. And measuring that out, that was 1/4 inch. And we have a ball peen hammer to drive out our shear pin. We can take measurements off of that square hole to try to duplicate the square end that has to go on this new cylindrical piece that goes in here. And then we also have to drill a hole and tap this for that proper size bolt. Now that punch is just the same, looks like the same size as the pin. So we'll start with that one first, see if it gets hung up, then we'll have to switch to the smaller punch. No, that's actually working perfect. There's enough play in here where it's still grabbing the pin itself, but there's enough play inside of the handle, the hole in the handle, that the punch won't get hung up. Okay, now I got to go rescue the pin from the floor. So here we go. We've got this part to take off, and then there's a rubber O-ring on there. So this is the part that we have to duplicate. So the other part that I found is a 3/4 inch of round stock. We have to go to our widest point on the part, and that's 0.7625, basically 3/4. This looks like might be brass. Yeah, that's a hunk of brass. That's not steel. Okay, that's what we want to find right there, is 0.75. Okay, so there we have a piece of steel, a piece of round stock. We can put our brass piece away. We don't need that. Okay, here we are over at the metal lathe. And we got our little piece we have to duplicate. We have our raw stock on rod here. Now you can run this, I believe, up to 3/4. So I want to use my 3-jaw chuck on this. So I was a little premature in running the stock in there. So I've tightened up the belt. I'm just going to go ahead and remove this. And all these come together at the same time, or the same distance apart, so that'll automatically center the piece. Now if I was smart, I would have disassembled one that was in good shape, or I would have took a measurement from the collar out to the very outer edge of this, but being as I didn't, I'm going to the highest point, which is it's right at an inch. What I need to do is determine how deep that needs to be. That's so badly worn that that's not even square right next to where this collar is, or this is so badly worn that this piece here, which is not damaged at all, won't fit flat up against this collar. So what I need to do is I need to determine how deep to make this from here to the outside, and actually maybe even just a little bit shallower, so when I go to tighten this up, this right here is going to fit up tight against this collar. So if I make this square part too tall, then this is going to have some slop in there, and the same problem might happen again. So what I need to do is make that either the same elevation or just slightly less, so this part, the center part, doesn't protrude too high up into the plane on this, so it fits nice and snug to this piece. So when you tighten it down with that nut, that's recessed a little bit, and then this piece right here, the latch piece, is actually going to fit tight up against the collar here on this piece that I'm trying to reproduce. So with that being said, this piece is 0.125. So this metal is 0.125. It moved after I took it off of there, but it's 0.125. I don't want that protrusion, or that height of that square piece, to be higher than 0.125. Now this piece right here can be 3/4 of an inch, or whatever the native width of this is. This looks a little oblong, so I'm going to go ahead and clean this up. But this piece right here on the widest point needs to be 0.5635. So I need to follow this all the way across, and then after I need to make this side flat, and this is square on the inside. And I don't have a milling machine for that, but we'll see what we can do. Alright, the first thing I want to do is take that slop out of that. It looks like that's where they cut the stock off at the mill or at the foundry. So I'm going to go ahead and clean this up. As you can see, this see how bent this is? And the reason I know it's bent is because it's sitting square in the chuck, but the cutter is only cutting off a certain portion of this on the back side. So we're at 0.73 right now, where the rod is a 3/4 of an inch. Now we'll have to cut this off to get this square again, so that point is out here somewhere. But technically I don't have to cut as much off. Okay, you can see right here, wherever they cut this off at the factory, this kind of oblong this a little bit and flatten this out in here, where they have the shears, and the shears cut this off. It mashed the round stock down. So right up in here is where it starts to get round again. So what we'll have to do, at least come to this portion right here with the 3/4 inch part of this project, and then come out here another 1/4 inch past this, because that's where it tapers down, so it would be okay to come out here. And then we'll just cut this off, and then we'll start afresh from this point here. Alright, that took a little while to do. Hey, I'm not saying that I'm a machinist by any small stretch, but I think we'll be able to get this done. And I might not have all the tools on hand that would make this really efficient, but again, we're going to make it work. Okay, the depth there should be 0.121. I'm over here at the tap and die set. I'm trying to establish what size hole that I need. So I ran over to my spare bolts bin, and I got this bolt here. Determined it was an 18 thread per inch, and a 5/16 drill would be required to make the hole. To verify that I'm not reading this wrong, I like to take the 5/16 drill bit and hold it up against the bolt. You can see the thread showing. That's good, because the hole that you make with the drill has to be a little bit bigger to cut in the thread. So use drill 17/64. Alright, there's a couple of little tricks here. What I've done is I've measured the depth of this hole with my gauge, and measure the depth of this hole, and I'm going to go just a little bit past on this one here to account for the taper of the tap. The tap has a taper on it, so I'm going to go just a little bit past there, put a bolt in there, see how it looks, and I might have to go a little bit deeper with that hole. We'll see. I could put this tap in the chuck. That would make it perfectly straight, but I think this will work just fine. Okay, if I measure this back here from the inside of the head to just the face of this 3/4 inch round stock, I can determine how much penetration or how many threads that I have of that bolt going into the round stock. Okay, I have about maybe 3/8 of an inch of penetration. Well, that should be enough, and that'll still give me plenty of room to have between where that shear pin goes in, so that hole won't come in too deep and interfere with where that through pin goes in and make this weak. So that's where that'll be. Okay, so this will be the back side. hole is drilled and tapped. Okay, I can use my gauge now to determine where I need to start tapering this down to duplicate this right here. So I need to make it round between my thumbnails, and then I need to flatten it between my thumbnails. This outer edge is the thickness or the depth that I need to go, how big I need to make the round portion of this stock right here. And then right here is how far in I need to penetrate. I'm going to use this cutter to make that a little bit more of a square cut. So now that we have this little stair step defined and finished, now we can go with this part right here. That'll be the widest part of this whole part. So now I'm working on this section right here, this tall section. Find out how wide that is. That's 7/64. Doesn't really mean a whole lot other than I want it to be able to fit inside the calipers. I'm going to try this bit. It's got a nice square corner, and then I can penetrate just to the left of the 3/4 inches and in the depth, and be able to cut that in and have a square edge on the back side of my stock. And I'll make sure that this bit is going to be 90 degrees to the round stock, and my cutter is going to be just right at the center of my material. I'm going to make this lip, this little standoff portion, just a little bit wider so I can kind of work into the right depth. Okay, that's right on. So now we need to define how thick this is going to be. Right in here, it's 9/16. Just like that's 9/16. Tighten this down at 9/16 and keep going until I get it the same diameter as the first portion of this. Okay, there's the sweet spot. I'll change bits again, make one, I'll put a bit in there that cuts a little better, a little faster. That side's got a little different shape to it. This side here I have to square off so it fits inside this square keyway. And this side here has to be flat on two sides to accommodate this articulating handle here. So have a little more figuring to do. So far it looks good.